Hello, everyone. I'm back again to talk about Blazor. In this presentation, I'm going to be covering some more technical concepts. This session is called Black Belt Blazor. I'm Sean Walker. I'm the founder of a boutique consulting company that focuses on Microsoft technologies called Devessence Inc. I've been a Microsoft MVP now for 16 years. I just received my notification last month that I was an MVP once again. I guess my claim to fame is that I am the creator of a few popular open source frameworks. One of those was .NET Nuke, which I created back in 2003, which is still a very popular web framework content management system. And I'm also the creator of a modern web application framework content management system called Octane, which I'll cover or talk a little bit about as well. I'm also a volunteer for the .NET Foundation. I've been the chair of the .NET Foundation Project Committee for the last 3 or 4 years, but I've been a volunteer with the foundation since 2014, since when it was originally founded. So this session, we're going to talk about Blazor. And in particular, there's a lot of, I guess, new information and things that happened around the time that .NET 8 was introduced, which was last November. Blazor got a lot of new capabilities at that time. A new render mode called static server-side rendering. And in a lot of ways, with those changes, there's differences in the way that Blazor behaves when working in static rendering versus interactive rendering. Interactive rendering is, of course, the rendering mode which Blazor used for the first 3 or 4 years of its existence. But anyways, with these new capabilities that Blazor has to offer, it does create a little bit of confusion sometimes for developers because things don't work necessarily in a consistent manner. And that's what I'm going to kind of dive into today, is explain some of those differences, maybe some of the limitations, and also some solutions on how you can get past some of the limitations you might run into. Most of what I'm going to share today are basically things that were learned as a result of migrating Octane, which is the open source project I just mentioned previously, from the earlier versions of interactive Blazor to .NET 8, and also modifying the framework so that it could support static server-side rendering. So Octane is a native .NET Core framework that uses Blazor for its user interface. It's both sort of an application framework and a content management system. It supports all of the different render modes that are available in Blazor, and it also supports Blazor Hybrid as well, which of course you can use in .NET MAUI. You can get more information about Octane if you're interested at www.octane.org. And typically I have a lot of slides which I run through as part of my presentations. But in this case, it's much easier for me to demonstrate some of these capabilities. And so I have a fairly elaborate demonstration that I put together. That demonstration is a Blazor project, which I'm going to publish as an open source project after this presentation is over, so that people are going to be able to download the code and actually experiment it with themselves as well. So with that, I'm going to switch over to Visual Studio. I have got a couple instances here. I'm going to run the project in this instance, and then I'm going to explore the code in the other instance. And so, of course, we have the standard Blazor project. This project was created using the Blazor web app template, which allows you to use the static server-side rendering capability that's part of Blazor. I've outlined a lot of different scenarios, which I'm going to run through in this presentation. They start with very simple things, and then they get to more elaborate scenarios as we get deeper into the presentation. But first of all, I'm going to talk a little bit about project setup. And I mentioned the fact that this project that I'm going to be demonstrating was set up using, .NET 8 and using the Blazor web app template, the default template. But I've had to make some modifications to the template, and I'm going to explain why. So if we take a step back for a moment, one of the reasons why Microsoft made some of the changes that it did in .NET 8 And in fact, originally the version of Blazor in .NET 8 was codenamed Blazor United. And the idea behind Blazor United was that developers shouldn't be forced to make decisions about the architecture and some of the more technical details about the project when they first create a Blazor project. And unfortunately, in interactive Blazor, that was often the case. It's as soon as you got started with Blazor, you were faced with this decision: is it going to be a Blazor server application, or is it going to be a Blazor WebAssembly application? And often, you didn't really know what the right decision would be at that point in time, but you were forced to make a choice, and then it was sometimes difficult to backtrack or refactor after you've made that decision. The reality is, of course, Blazor supported multiple hosting models with interactive Blazor. And really, the limitation was around the templates that were offered by Microsoft. So there was a Blazor server template and there was a Blazor WebAssembly template. So, I mean, when you're spinning up a new Blazor project in Visual Studio, you have to make a decision at that point. And so you were forced with sort of this fork in the road that you had to choose one path. And maybe you weren't clear on which path you should choose at that time. And so that was like one of the ideas that Microsoft wanted to try and resolve in .NET 8, is to try and take away, some of these early decisions so that there wasn't a fork in the road. Unfortunately, I would say that the default Blazor web app template in .NET 8 still suffers from this same problem. It allows you to get set up initially with a static server-side rendered project, which allows you to use interactive components so long as those interactive components are running on Blazor server. However, if you want to use Blazor WebAssembly, or use the new auto mode, or use Blazor Hybrid, the new Blazor or the default Blazor web app template is not going to work for you because it's not set up in the right way. And so because of that, it's still a problem in that developers cannot take advantage of all the capabilities of Blazor without doing some initial refactoring, and they don't always understand what type of refactoring they need to do to be able to use those other capabilities. So unfortunately, I would say there is no template that's offered by Microsoft today, at least within Visual Studio, which sets up a developer for success to be able to use all of the different Blazor capabilities. And I'm going to explain a little bit more about the changes that you need to make in order to be successful, to be able to use all the capabilities in Blazor. And so the main thing that you need to think about is if you are running Blazor interactive render modes like as WebAssembly or Auto, or even trying to take advantage of Blazor Hybrid as part of .NET MAUI, you need to think about your application as a client-server application. So you need to put your components in a separate client project. So basically, this is just following best practices, separation of concern patterns, so that you can clearly understand the difference about what workload is happening on the client versus what's happening on the server. But the default web app template is designed with a single project, and it sticks all of the components into that project. And so it's not really that suitable for doing anything except for server-side Blazor. And so I'll explain how you have to rearrange the project to make it work with the more client-side capabilities of Blazor. The other thing that I think that needs to be noted is that in .NET 8, when you're using Blazor and you're using the new capabilities, the static server-side rendering capability, initially, when Microsoft talked about this, it sounded a lot like they were just bringing the capabilities of like older UI technology, such as MVC or Razor Pages, and merging those into Blazor. To some extent, that might be true, but the reality is by default, when you're using static server-side rendering in Blazor, it has this new capability called enhanced navigation, which is enabled by default. And enhanced navigation is essentially like a UI abstraction layer, and it affects how the web application behaves. You're not dealing directly with request response scenarios like that you're used to on the web. There's this layer that's in between that is intercepting the requests and the interactions between the client and the server. And that makes some things a little bit more complicated. And unless you sort of understand what the capabilities of enhanced navigation are, you may run into some challenges in trying to take advantage of Blazor static server-side rendering. Render modes. So up until .NET 8, Microsoft referred to the different capabilities for hosting applications in Blazor as hosting models. So you had a Blazor WebAssembly or a Blazor server hosting model. With the addition of static server-side rendering, we now have this new notion of render modes. And there's two different ways that you can use render modes within your Blazor application. The way that Microsoft describes it in their documentation is you can use it on an instance of a component or in the component definition. And I'll get into a little bit more about this, but the difference between these two is when you put an @render mode attribute directly in your component and specify what the render mode is, essentially you are hard coding a behavior for that component. And that is not the recommended way of using render modes. The idea behind render modes, especially if you're building reusable components, is you should be able to use them in different render modes. And so you don't want that hard-coded behavior in the component itself. So when you reference that component in a different component, that's where you would specify the @render mode parameter. And that parameter makes it an instance. And that parameter, of course, can be dynamic and it can change, which allows your component to operate with different types of behavior. So the render mode specification can be abstracted and it can be specified as configuration. And in the project I'm going to show you, I've actually abstracted that so that I can specify the render mode within my app settings.json file. And so I can specify it in one place and it affects all of the components in the application. And so I can say, oh, I want all the components in my application to use interactive server. Or with one change, I can change it and make them all use interactive WebAssembly or auto. And so because of that, it just provides you with a lot more flexibility. The other thing which a lot of developers have struggled with is, of course, in .NET 8, you have the notion that you have the sort of the best of both worlds, right? You can use the capabilities of static rendering and you can use the benefits of interactive components. However, there are some challenges to be aware of when you try to mix these different render modes within the same application. And ultimately that boils down to something called render mode boundaries. So render mode boundaries are when your application transitions from a static component to an interactive component. As part of that transition, essentially those components are running in different processes. And because of that, things don't naturally flow from one component to the other if they're in different processes. And so things like state, which at least when you were building interactive Blazor applications, one of the great things was it handled a lot of the state management for you. And that state could be passed from one component to the next without much difficulty using a variety of methods. Well, that state doesn't transfer when you're using a mixture of both static components and interactive components. And I'll demonstrate a little bit about how that works as well. So first off, I'm going to transition over to Visual Studio. And so this initial project setup looks a lot like the way that the default web application template scaffolds code for you. I've added a few additional folders here, but generally you have a project, you have some components. Usually within this components folder, you have a pages folder, which has your page components. And then, of course, we have our main app component as well, which resides in components. As I said earlier, the problem with the way that the default web app template configures your project is that it's really designed for server-only kind of interactions. If you want your project to be able to handle client-side interactions as well, such as WebAssembly or hybrid or other scenarios, you need to create a client project. So I have created a client project here, and I've created a components folder, and I've actually just simply moved my layout files from my components folder in the server project into the client project. So these are the exact same components that you're used to seeing scaffolded for you. I've also created a pages folder and moved all of the pages that were in the server project into the client project as well. I also moved the routes component as well. And so by moving all of these components out of the server and into the client, it allows these components to be used in a variety of different scenarios, both server side and client side. And I guess maybe I should explain a little bit more about why this is important to configure your project this way when you're trying to take advantage of client-side Blazor. And so like when you're using client-side Blazor, for example, Blazor WebAssembly, the assembly that relates to your components needs to be downloaded from the server to the browser. And it actually, is transferring assembly to the browser, and then it's running that assembly natively within the browser using WebAssembly. You would not want all of your server-side logic to be inside that assembly and transferred to the browser. That would be a problem for a multitude of reasons, right? Security, you would have dependencies that are being transferred over to the client that shouldn't be on the client. For example, things like data access or HTTP controllers, or basically there's a lot of stuff that needs to stay on the server. And so that's why you have to structure your project differently so that you keep your workloads that are related to the server on the server, and your workloads that are related to the client can go on the client. That's why you need this separation. And so I have a whole lot of pages with components that I've created here, which correspond to the different scenarios that I have outlined here in my browser, which is running. And so I'm going to go into each of those in a moment. I think let's start with the very first one, which is sort of the simple like button click scenario. So I have a page here. So this is a standard, Razor page. So I have the @page directive. It's going to respond on this route, button click. Within this page, I've set the title and some various things. And then I've set up 2 different components. So these are standard Razor components. These are not page components. So I have a button interactive component, which is going to be rendered based on what the render mode is based on that I've set in the configuration. And then I also have a static component as well. And so if we go back and we look at the button click scenario, this is what it looks like. So of course it's got the button click page, and it's got the 2 different components. And it basically tells me which render mode these components are using. So overall, the entire application is running using Blazor static server-side rendering. So that's, all of the navigation, the default like app, the default routes, they're all using like static server-side rendering. And then on each of these pages, I'm going to have both a static component and an interactive component. I'm going to be able to show you the difference on how they behave. So if we switch back to Visual Studio, so we have the page, and then if I look at the sort of button interactive, this is like the standard component that you see scaffolded in the default web app template for Blazor. So you've got a button and you've got an on-click event. And when you click of course, the button, it's going to increment the counter. And this kind of nice interactive flow has been possible since the very beginning with Blazor. And so if we go back now to my running application, and if I click the button, we can see that the state, which is the page sort of variable that's part of that component, retains the state. And as I click, the count increases. That's great. What about the static rendered component that's basically running the same code? What happens if I click the button here? Nothing at all. Static Blazor does not support the on-click sort of attribute that you're used to using when you're using interactive Blazor. And so because of that, you cannot use that approach with buttons that have on-click handlers and events that are hooked up to them. You have to use a different approach. One of the approaches that you can use is the approach that I have sort of outlined here. So this is called the button link component, and I'll go back here and I'll take a look at the button link. So again, I have a page. In this case, I have a button link interactive and a button link standard. The button link interactive is basically, it has two buttons, but it's using the onclick method because it's an interactive component. So it's allowed to use the onclick methodology. We'll maintain state. It'll increase the page count. The button link static is using an alternative approach. So in this approach, it's basically using sort of old school traditional buttons, with links, but with query string parameters. And so this is how it's going to maintain the state, is on the query string. And as I click these links, they're going to sort of increment, but it's going to utilize the query string to maintain the state. But it's going to be able to simulate basically the same exact behavior that is available on interactive server. So interactive server, I can click to move the page forward and page back, and this is using the onclick method. Whereas the static method, if I click, we'll see that the page changed to 2 in the query string, page 3, page 4. So you can rewrite, of course, the way that you've been doing some of your interactive capabilities in Blazor or using the so you have been using the interactive method. You can redo them using the static method. And these static methods will work just as well in interactive Blazor as they work in static Blazor. So that's one approach, right? Not a lot of people don't always love query strings and sort of the older school methodologies, but clearly that this works using Blazor and using static components. So let's look at another approach now. So this is again using a button, but in this case, it's going to use a form to handle the static rendering scenario. So if we move back to Blazor again, we have the button form page, and we're using this sort of the button static component. In one case, it's going to set the render mode to interactive. In the other case, it's not setting the render mode, which means it's going to be rendered statically. It's setting a form name, which is important. You need to be able to set a form name for a form. And let's take a look at the button static method. So in this button static method, we now have a form element, and that form element has to specify method equals post on it. So this is one thing that static Blazor does support, is the ability to specify an @onSubmit sort of attribute, which can be used then to hook up an event. So when someone submits this form, it's going to call this method, and it's going to increase the counter. The form name was passed in as a parameter, as I showed you from the page component, and it is using the new enhanced navigation for forms capability, which allows static Blazor to simulate sort of a single page application behavior. So basically, it feels like it's not doing a full page refresh to the end user. You have to provide a reference to the anti-forgery token as part of your form element, or else it's not going to work. And then you can have a button. That button, instead of type equals button, will be type equals submit, because when people click the button, you want it to submit this form. And that's about it. So in this case, this is how you would wire up a button using a form post approach instead of using the Blazor interactive approach. And so if we go back to the browser, we can see that, of course, the interactive server is still using that approach. Well, actually, if we switch over back to here, we can see that the button form, both of them are using this exact same component. One of them is running it interactively, and one of them is running it statically, right? But it's the same component that we just looked at with this form methodology in it. And you're able to see that when it's running interactively, this form approach works fine, right? So it's doing a form submit, and it's hooking the event, and it's increasing the counter, and it's maintaining the state. Great. The static one, we can click it, and it also works. However, you'll see as I keep clicking, it's not maintaining the state anywhere because it's being re-rendered statically every time I click it. So although the button click is reaching the event handler and increasing the count, that sort of counter variable is not being maintained in memory as any sort of state, which would be normally the case when you're using interactive Blazor. And so because of that, the counter is not going to increase any further, and you'd have to use an alternative method to store that state somewhere, maybe on the query string, maybe in the form itself. That, of course, would probably be the superior method to use in this case, because, of course, a form can maintain state as well. All right, so these are very simple examples for very basic primitives like buttons. So I've mentioned that there's sort of, a couple of different ways that you can wire up buttons in static Blazor. But of course, the implementation looks completely different than it did in interactive Blazor. All right, so what about a form? So this is like, an actual form, which is pretty typical of things that you would create in Blazor. So we'll look at simple form. So simple form, here's the page component. We've got a simple form interactive component and a simple form static component. If we look at the simple form interactive, this is how you would typically create forms in traditional interactive Blazor, right? You'd set up labels, you'd add inputs, and you'd have a button, and then you could wire up the onclick to submit the values, and wire up the event. This is all pretty straightforward, a very good developer experience. If we look at the simple form static, of course, we can't use the same approach, so we have to use a form again. So we have a form, method equals post, and then we've wired up the onSubmit method. We're putting our anti-forgery token in, and then we've included all of the UI elements that we wanted, the first name and the last name, and we've included a submit button. That's all great. In order to do proper data binding, though, with forms in static Blazor, you have to do a little bit more. So you have to declare some backing variables for the form elements, and you have to use the supply parameter from form attribute, which is going to basically, the name is important here. So this name, first name, has to match the name on the inputs that it's related to. And then it's going to basically transfer the value through data binding into these local variables, and it's going to print the value. So this looks a little bit different, of course, than interactive Blazor, but it's going to basically accomplish the same thing. And if we go back to our browser, I can type my name, and I submit the values in interactive, and I can see the values were submitted, and I can do the same thing with static, same thing. So you can accomplish essentially the same sort of interactivity that you can in interactive Blazor, in static Blazor, but you have to write the code in a different way. This code that I showed you for the static Blazor approach, this code will execute just fine in interactive Blazor as well. So essentially, if you want to write a component that captures information from a form, if you write it in this way, this logic will work regardless of whether that component is being run in a static scenario or interactive scenario. So it's essentially like your lowest common denominator. If you want like interoperability between different render modes, this approach works both ways. Whereas this interactive approach will only work in interactive Blazor. All right. So what about if we want to create a little bit more advanced form? So, and this was pretty common, it's not often that you have just a few simple inputs on a form that you need to handle. Often you have a lot more advanced scenarios that you need to handle. So when you are developing on interactive Blazor, you could use other types of events, not just onclick, right? You could hook onchange. Like here's an example where I'm specifying whether the user is a software developer or not. And if I choose, it'll automatically use the onchange event, capture the value, and it says no or yes. When I try to do the same thing with static Blazor, Nothing, because there is no onchange event that's available in static Blazor. The only way that you could essentially accomplish the same thing would be to actually put JavaScript onto this element so that it reacts to the user interaction. However, at that point, then you're in JavaScript and you may have to call back into C#. It gets a lot more complicated. So I guess this is the sort of the one recommendation that I would make is if you have more complex forms where you expect the user to interact with them and they have a lot of different, combo boxes or, like select elements that are going to react and perhaps show other elements on the form, interactive Blazor is by far the much more efficient approach for developers to use to build elaborate forms. Static Blazor, you can get it to work, but it's just going to take a lot more effort. The other aspect of this more advanced form is, of course, we don't just have one button here. We have multiple buttons. And so that was, easy. If I hit submit 1, right, I would be able to hook the event, or submit 2, I could hook the event again. On static Blazor, if we take a look at the actual component, so this is the advanced form scenario. And if we look at advanced form static, you'll notice that on my buttons, they're submit buttons, but I had to include a name and a value so that I'm able to basically interpret which button was actually pressed. And so I have a variable for action, and I've done a supply parameter from form, which is action. And so when that gets submitted, I'm going to be able to determine which button was pressed. And basically they still call the same event handler, but that's how you can handle multiple buttons being pressed in a static form. So this works as well. So you can support multiple buttons, but again, you have to sort of use the older sort of traditional web methodology to do that and specify name and value to be able to differentiate. Whereas, with the traditional Blazor or the interactive Blazor approach, you just specify onclick and specify, whatever events you wanted to handle. So again, different methodology, different coding approach to handle the interactive versus static Blazor environment. All right, so moving on from there. What if we wanted to have a progress indicator? And this was something that, pretty common in interactive Blazor applications where someone clicks a button and maybe the server's, there's going to be a call to get some data or something, and you want a spinning progress indicator to appear on the page like this, right? So you click load, shows a loading indicator, and then it goes away. Pretty simple to do in interactive Blazor. So let's take a look at that. So if we look at progress indicator, so we have a component, a page component. We have a progress indicator interactive component and a progress indicator static component. The interactive version is pretty basic, right? Basically, I have a CSS class, which is how the spinning image is going to be displayed. I have a load button. When the load button gets pressed, it's going to set a loading variable. It's going to do a state has changed to refresh the UI. It's going to wait 2 seconds, and then it's going to turn off that loading indicator and refresh the UI. So this is very simple. And you've probably seen this code a lot of times. How would we do the same thing with static Blazor? Well, it's a little bit more tricky. So again, we can have the loading indicator. We're going to use a static form to handle the button click. However, and then the code's going to look very much the same, right? You're going to set loading to true. You're going to call status changed. You're going to wait 2 seconds. So this all looks very similar except for the form. However, if I do not include the StreamRendering attribute at the top of this, you will see nothing because there is sort of no interim state in a static component where it would be able to show the indicator. So StreamRendering is a new capability in .NET 8 as part of static server-side rendering, and it basically, pushes sort of multiple sort of renderings of the content to the UI. And so by adding this attribute, it'll be able to display the sort of interim state of like the state has changed values. So, and I guess the other thing I should mention is if you're using StreamRendering, you have to also be calling asynchronous methods, because it's sort of the asynchronous await that causes the stream rendering to push a batch of sort of content to the UI, and then it'll continue until the method is completed, and then it'll push the remaining content to the UI. So if we go back to the progress indicator, and I can say click me, and we get the standard loading behavior, just like we had an interactive server, right? So they work consistently, but again, the implementation is different. All right, so that's progress indicator. Scroll position. So if I click on this scroll position page, I got a whole lot of sort of lorem ipsum type content in here. If I scroll to the bottom of this page, right? So I have a scroll position in my browser that is, down my page. I have a scroll position 2 page as well, which has a similar amount of content. Normally, when you navigate from page to page in a web application, your scroll position is reset to the top of the page. That's what users expect, right? They expect the scroll position to be reset to the top of the page when they move to a new page. If we take a look at this and I click on scroll position 2, you're going to see that I'm still on the, like I got moved to scroll position 2 page, but I'm at the bottom of the page. It did not get reset to the top of the page. Similarly, if I'm at the bottom of this page and I scroll back or go to scroll position 1, I'm again at the bottom of the page. This is not the greatest behavior. And then it is one of the challenges of enhanced navigation, unfortunately. This problem has not been resolved in .NET 8. I have not seen if it's been resolved in .NET 9 yet. But if you're building sort of public-facing website pages, this can be a bit of a problem. And a lot of people have complained about this online. There is a way to fix this. So if I, stop running this application, and I go to my app.razor, I've included a little JavaScript snippet here, which I will uncomment. And essentially what this JavaScript snippet does is it basically monitors the URL path, and if it determines if the URL path changes as part of navigation, it resets the window scroll to the top left, which means that I'll get the consistent type of behavior that I would expect as I'm running the application. All right, so if I go back to my application, let's build the solution. Oh, that should work. All right, and let's run the application again. All right, and I'll go back to my scroll position, and I scroll to the bottom of the page, and I go to scroll position 2. It moved me to the top of the page, like I would expect it to. And I'm on the bottom of this one, and I go back, moves me to the top of this page. So a very simple sort of JavaScript hack, so to speak, I guess, you can put in your app.razor file will handle this scroll position problem fairly simply. And this works quite well. All right, moving on to the next item, NavigateTo. So NavigateTo is a method that's part of the Navigation Manager, which is a very common class that you're going to use as part of Blazor to navigate to different URLs that are part of your application. So if we go back to the code for a moment and we take a look at this NavigateTo page, we'll see that there's 2 components here, a NavigateTo interactive component and a NavigateTo static component. NavigateTo interactive just is going to navigate to the the root page, the home page of my site. I'm going to click a button and it's going to navigate there. I also have a NavigateTo static as well. This is using a form post, and it's wired up the button, and it's going to call NavigateTo, and it's going to call NavigateManager.NavigateTo. All right, so let's take a look at what happens when we run this. So when I'm running an interactive Blazor, and I say navigate to home, it takes me to the home page, just like I would expect it to. If I try to do this in static Blazor, boom, I get an error. I get a navigation exception error. And for .NET 8, Microsoft's recommended approach for this to deal with this problem, since this does not happen in production. This only seems to happen in Visual Studio when you're debugging, is to basically, turn off this and say, do not break when this exception is thrown. And if you turn this off, then Visual Studio will remember for this application that it shouldn't throw an error. It'll ignore the error that's thrown and move on. This is not great. I always hate to turn off exceptions like this that are the defaults within Visual Studio, but hopefully Microsoft solves this problem in .NET 9. This has caused numerous issues to be reported, at least for my open source project, because developers do not expect this. They think this is a bug in your application. And I can understand why. It feels like a bug when it throws an error message like this. But this is unfortunately just the way that static Blazor works currently in .NET 8. So we will shut that down and rerun the application again, because essentially once you've crashed in Blazor, it's doesn't recover that well. So let's take a look now at OnAfterRender. OnAfterRender is a method that is part of the sort of life cycle of a component. In interactive Blazor, it's usually used when you're invoking JavaScript interop methods. But we can see here, there's a difference in Blazor static rendering in that the OnAfterRender is never called. So if we take a look at the components for this, OnAfterRender, we have the page component, we have an interactive and static version of those components. In the interactive version, we can see that we have the method, and we're just going to display a message when this method is called. And in the static one, we're trying to do the same thing. But when we ran the application, of course, we can see that the method is called when running in interactive, but it's not called in static. So this is just something to be aware of. So obviously, if you're doing JavaScript interop in static or in interactive Blazor, the fact that you can't access OnAfterRender in static Blazor means you can't do JavaScript integration in the same way. That's one clue. Also, if you're doing any other type of business logic as part of OnAfterRender, it's not going to be called in your static components. So probably something that needs to be avoided if you're trying to build components which work in both models. All right, getting into a few more complex scenarios now. Cascading parameters. So cascading parameters were a very common way of passing state through a component sort of render tree in interactive Blazor. So you could basically set some state in a sort of high-level root component, and then that state was accessible in all the child components that were beneath it in the render tree. This was super convenient for passing state and allowing all of the components in your application to have access to it. You'll notice that when I execute this particular page with these two components on it, so this application, I'm going to remind you, is a static rendered Blazor application. And this is an interactive component. So this is one of those scenarios where we're crossing a render mode boundary, right? So the application starts off with static components, and then in this particular case, it's transitioning to an interactive component. And you can see that the cascading state value is not passed automatically across that render mode boundary. It's null. Whereas the static component receives the value of the cascading parameter. So if you have purely static components, then if you set a cascading parameter in the root, they will be passed all the way through the render tree as long as those components are static. That state will be persistent and you have access to it. If any of those components are interactive, you will not have access to it. And this caused a lot of challenges for developers as well. So that was one example of passing state, which is different with static Blazor and interactive Blazor. Scoped services are another example. So scoped services are another convenient way of passing state to various components in your application. Basically, in your client project, you would declare a scoped service. That scoped service would usually probably be a model of some sort. You'd populate that model's properties with values, and then you'd inject that service into your various components, and you could get access to the state. However, again, we have the same problem when we're crossing a render mode boundary. So if we set the app state for this in a scope service in a root component, and now we've crossed a render mode boundary into an interactive component, we're going to find that the app state is null. It hasn't made it across that render mode boundary, whereas the static component still has access to that state. Both of these are challenging problems to deal with. And there is a way that you can deal with it, which I'll explain here in this past state component. So we'll switch back over for a moment and we'll look at past state. So the past state page has two different components. It has past state interactive and past state static. The past state interactive component has a few additional parameters on it. So these are like traditional Blazor component parameters. So essentially what I'm doing here is in my page component, I'm getting access to my app state scoped service by injecting it, and then I'm passing it on as a normal parameter to this component. Similarly, I'm grabbing the cascading parameter and I'm passing that like explicitly as a normal parameter to my past state interactive component. So if you looked at past state interactive component, it has a couple of parameters which have the values that are coming in as regular parameters. But by doing this, I can basically transfer this state across the render mode boundary. I'm doing it manually and I'm doing it explicitly, but it works. It allows me to transfer this state across and get access to it again within my interactive component. So if I look at past state, we'll see interactively, I have the cascading state value and I have my app state values as well. So this works consistently. However, I had to manually pass the state across to make this work. Not challenging to do that, but sort of challenging to understand why it doesn't work in the first place. And this was a challenging problem for a lot of Blazor developers. All right, so now we've sort of tackled that you can pass state across render mode boundaries, right? You can pass state from a static component to an interactive component. So now I'm going to show you sort of a downside of that, which you need to be aware of. So we're going to go to a page called ViewState. Obviously, I call it ViewState is the sort of technical term that many web form developers were familiar with, where ViewState was essentially state related to UI components that was stored in the output of the page itself. Most people think that Blazor doesn't have ViewState. They are wrong, because in some cases, if you're transitioning from a static rendered component to an interactive component, so you're crossing a render mode boundary, any of the parameters that are being passed are actually going to be injected and stored into the page as essentially ViewState. All right, so ViewState 1. This is a static page with a static component on it. And if I go and find this code for this ViewState page, we're going to see that I have a list of items. So I'm building a list of 500 items. And these items are, just a list of strings, but these strings are pretty long, right? It's just a bunch of lorem ipsum text, but it's a fairly large string, 500 of them, and it's going to pass these items as a normal parameter to this ViewState static component. And then it's going to tell me in that ViewState static component how many items there are. So that's what we just looked at here. And it tells me there's 500 items. If we look at the browser tools here, and we look at the network tab, and we sort of refresh this page for a moment, and let's just look at the HTML document. So let's refresh again. we can see that the payload size of this page is like 9 kilobytes, pretty small, right? Because it's essentially just like the markup for the page. There's nothing else that's being handled here. Watch when I go to this ViewState 2 page. So the ViewState 2 page, whoa, it actually needs to reconnect SignalR. So this is a page that is static and it has an interactive component on it. So in this page, I'm crossing that render mode boundary. I'm doing the exact same thing where I'm building a list of 500 items. But take a look at how large the page size is now, 951K. How did it get so large? Well, if we take a look at the page source for this page, we're going to see something down in the bottom here, Blazor component state. And this value, it's kind of hard to see in the browser, but it is massive. I don't even have a scroll bar that I can move. Oh, here we go. So, oh, actually, sorry, it was this one here. This is basically the view state in the page. And if I scroll, look at the massive view state that was put into my page. So this is usually, I think, something that most developers aren't aware of, that when you're crossing render mode boundaries, you really need to pay attention of how much state you're passing. Like this probably is a contrived example, right? It's probably most people aren't passing collections of 500 very large strings as parameters to their components, but you might be passing a lot of state to your parameters. And in those cases, you might all of a sudden find that your application is performing less optimally than you would hope. And if you look at the size of the page output, you'll realize that there's a bunch of view state essentially that's in your page. So something to be aware of. All right, next example, serialization. So you can pass values across render mode boundaries, right? And here's an example where I have a static page with a static component, and I'm passing an object across that boundary. So here's my serialization page. I have a serialization static component, and I'm passing a parameter, and it's a URL parameter. And this URL parameter is a model, which I can show you. It's in my it's in my models URL. And so here's my model. It's just a very simple model. The thing to notice here is that it has a parameterless constructor. Objects that don't have a standard parameterless constructor cannot be serialized. This is important to note. So if we go back to this serialization 1, no problem whatsoever with the fact that that model doesn't have a parameterless constructor. Right? It works just fine. Serialization 2 is going to be a page with an interactive component. So again, we're crossing the render mode boundary. We're passing a parameter. However, that parameter is not serializable. Because of that, Blazor is not going to like it. And I'm a liar, apparently. I don't know how that worked. Maybe I changed something when I was trying to get the demo. But because it doesn't have a constructor, normally an error would be thrown. There we go. So if I refresh the page, you'll see that you get sort of this unhandled error. And if we look at the browser tools, you'll see the list of component operations is not valid, which is like a very obscure generic error message, and doesn't actually help you determine why this error happened in the first place. So this is just something to be aware of. Your parameters need to be serializable if you're going to be passing them across render mode boundaries. All right, so dual service. So if I transition again over to the code, this is one of my pet peeves with the default Blazor template, is it has a weather component in it, right? The standard weather component. And in a default Blazor application, it's basically supposed to simulate a service call, meaning like you're getting weather forecast information from somewhere and showing it in your UI. In the default template, it basically just creates some mock data in the component itself and doesn't call a service and doesn't actually help a developer understand how a service would even be configured to make it work. So that's a big pet peeve of mine because, you know, that's something that's pretty common that all developers need to know how to do. So in this project, I have my weather service, but I've sort of called it dual service. It's this page here. So we have a page, we have dual service interactive and dual service static. The dual service interactive component displays the forecasts. However, it actually calls a service. Similarly, the dual service static also calls a service. The thing to be aware of with these services, however, is that we have an interface which I do not. Okay, so let's so first of all, in my server project, I have a controller and I have a service. So to explain what actually happens here is if I'm running this project on using static rendering, which is server-based, or I'm using Blazor server, which is server-based, I want to basically call a service which gets the data. In theory, it would be coming from a database probably, but I want to get the data on the server. I don't want to have to make like an HttpClient call. Everything's running on the server anyways, so I don't want to impose any overhead to get this forecast data. I want to get it on the server. So that's what this weather service does. So I have a weather service that's implemented get weather async. It gets the simulated data and returns it. This approach, of course, will not work when I'm running the same component and trying to get weather service data when I'm running it in Blazor WebAssembly, because in that situation, the code is running on the client and it's going to have to make a call to the server. So that's why I have a controller on the server to accept the HttpClient call, and in turn, it will call this same service and get the data. And if we go down into my client project, into my services, I have a weather service, which is using HttpClient, making a get async call to the endpoint, which I just showed you the controller, to get the data and return it. So this would be executed when I'm running on WebAssembly. I have the same exact interface for this get weather, like this iWeather service, same exact signature. And what this allows me to do is in my dual service method, if I go back up to here, at runtime, it will be able to figure out which service implementation it needs to call. If I'm running on Blazor WebAssembly, it's going to know that it needs to call the service that is defined in the client project, which is going to use HttpClient, get the data, and it's going to work. If I'm running on Blazor server, it's going to be able to figure out that I need to use the service interface that's on the server and avoid HttpClient altogether. This works perfectly. So that dual service approach, I have interactive server component and I have a static component. Both of these are in fact running on the server, so they work just fine, and they will get the data on the server. I'll show you in a minute. Actually, we can close this, and I will, since I haven't even demonstrated this yet, I will switch over and I will run this entire application on WebAssembly simply by changing this one render mode attribute in my app settings file. So if I run the application, it's now running on, like if I go into any of these, I'm running on interactive WebAssembly now, and all of the things that I've shown you so far continue to work. If I go down to the dual service page, it works as well. In this case, this component is basically calling HttpClient. It's calling the controller on the server. It's getting the data and it's returning it through that mechanism. And so this is how you can create sort of a dual service approach so that your components adapt to the runtime environment to get the best processing capability. Pre-rendering also uses this sort of the same model, except in this particular case, there's a little bit of a delay. So if I refresh this page, you'll see that it takes a little bit longer for the WebAssembly rendered component to get the data and display it. This is because I've actually turned off pre-rendering for this particular component. And I can show you that if I... So if I look at not dual service, but pre-rendering. So the pre-rendering page is calling this pre-rendering interactive component, and it's using a utility method that I have with getRenderMode. This second parameter basically is a parameter which specifies whether or not to use pre-rendering when it renders the component. By default, it uses pre-rendering. In this particular case, it is not using pre-rendering. Because of this, there is a benefit. One benefit is that the component does not render multiple times. So one of the problems when you're rendering components is the OnInitialized async or onParameter set method may get called multiple times, once for pre-rendering and once during interactive rendering. So it's basically getting data twice, and it doesn't need to. If you disable pre-rendering for the component, it's only going to get the data once. But the downside to that, of course, is there's a little bit of a delay, whereas the static rendered one got the information on the server and was able to render the component immediately. All right, a couple things remaining, and I know I'm over time, but JavaScript is implemented in a completely different way when using interactive Blazor as opposed to static Blazor. So JavaScript, we can see that there's a static, there's basically an alert that's being raised through JavaScript in my static component, and then there's an alert being raised through my interactive component. In order to do the and, you'll see that as I transition from page to page, it happens in a consistent way. So it doesn't just happen on the initial load of the page, it's happening on every page transition. This is a challenging aspect of static Blazor to deal with. And so if we look at the JavaScript example, we again have a page component with the two different components. The interactive version is using OnAfterRender async, and it's using standard JavaScript interop. So this is the way that traditionally Blazor developers would always interact with JavaScript. And this works just fine. However, the static component is actually doing something kind of interesting here. So there is a component that was created by McKinnon Buck from the Blazor team, and it's called PageScript. And you can find it online with just search for Blazor PageScript. And it basically has this sort of convention that allows it to handle sort of JavaScript in a slightly different way. So this JavaScript static file, if we go find it in my www.root folder, it's in my server project. Hold on here. It's not in my, there we go. So if we look at the difference, so JavaScript static is this one here, and we're going to show an alert, but this show alert is only going to be invoked when this function for onInvoke is called. This onUpdate function is basically wired up through this JavaScript library, which McKinnon Buck created. And it's basically a custom element. And when obviously Blazor sees that custom element, it wires up events. So it can wire up 3 different types of events. I don't know if I'll be able to find them in here, but there's like an onUpdate, onLoad, and onDisposed events. And so simply by having this JavaScript library in the project, I can put my components JavaScript file into my www.root folder, and then I can wire it up in my components JavaScript static area, and it works. So basically, as I navigate from page to page, it'll basically execute this JavaScript method, and it'll show the alert. So the last thing I wanted to mention, and I have no demo for this, so authentication. Authentication is challenging in static Blazor. So static components can access HTTP context via Cascading Parameter. I actually have an example, I think, of this in the project. If I look at my app component, here we go. So I have a cascading parameter with HTTP context. So in my root component, my app component, I can get access to HTTP context because this root component is running on the server. It's running static server-side Blazor. And I can get access to different aspects of the context in my root component. That works fine. However, the recommendation from Microsoft is you should only be using that in your root components. You shouldn't be using it in other components that are further downstream. If you want to use values from the HTTP context further downstream, you probably should be loading those into some kind of a state container, like a scope service or something, and then giving access to those other components to that service. Interactive components don't support HTTP context. They never have. And you're not supposed to use HTTP context accessor either in interactive components. So if you're trying to create components which deal with authentication, and since if you're coming from a more like MVC or Razor page background and you're used to using HTTP context for everything, you're going to run into some challenges with Blazor. The recommended approach for dealing with authentication in Blazor is to use authentication state providers. And you can find lots of documentation on that. And I will say that it is possible for a Blazor application to support authentication using all the render modes and all the hosting models. The Octane framework does this. It basically has multiple authentication state providers so that it can work with Blazor WebAssembly, Blazor Server, Auto, and Blazor Hybrid. All using sort of a cookie-based authentication approach wired up to dot and identity. I think like you'd need an entire session to cover just authentication alone because there's a lot of different pieces to the puzzle. And I would also mention that in .NET 8, Microsoft did provide scaffolded like auth components for Blazor applications, right? When you're creating a new Blazor application using the web app template, you can choose to include to scaffold the auth components as well. The thing to realize, though, is that those auth components are using static rendering, and they reference HTTP context. So they do not work if you want to make your entire application globally interactive. Basically, those scaffolded components will not work in that scenario because they rely on HTTP context, which isn't available. So in .NET 9, there is a sort of workaround solution that Microsoft is creating for this, a way to basically carve off a part of your interactive Blazor application and say that, all of the components on this particular route are static, and that would allow you, and perhaps like those could all be part of like some auth path. And so in that way, then you could support the static auth components in an interactive application, but that is not coming until .NET 9. All right, so I covered a lot, and I know I'm a lot over time now, but there was a lot to share. As I mentioned at the beginning, I'm going to post this particular project that I demonstrated as an open source project. I'll be putting it on GitHub in the Devessence organization so that you can download it and play with it if you want to. And with that, I want to thank everyone for coming to this presentation. Obviously, if you are looking to build advanced sort of, robust Blazor applications, Devessence is a consulting company that is capable of helping you with that. And so feel free to reach out if you need additional help with that.